Jet, can you reach this? Thank you. Thank you, thank you. Okay. So first and foremost is quadratic functions, right? You should realize that it will have an x squared term in it. And in grade 10, you factored, you remember factoring quadratic trinomials? I don't know if you remember that. You had to take a trinomial and turn it into two brackets, right? And you had to figure out what goes there. You were actually dealing with quadratic functions. If you had graphed it, it would have been a quadratic, okay? So the graph shape is called a parabola. Okay? And it looks like a horseshoe. Okay, that's what it looks like. And so I will just quickly on the cover here. And so imagine this is your x and y axes, right? It could look like this, where it points up, like it kind of looks like that. Or the other option is to have your x and y axis, and it kind of looks like this. It could be off-centered, it doesn't matter. There'll be any variation of these two, that's what you're going to see. Okay? And there are a couple of points we're always interested in. Okay? In particular, look at this parabola here. If you go, just like you read a book or a sentence, you always read it from left to right. Same with graphs. So if you look at this graph and you start to the left, it drops until it reaches the lowest point here, and then it changes directions and it goes back up. That right there, that point, in this case the lowest point, that's a turn, okay? And we call it vertex. In this case, it's actually also referred to as the minimum, and it's sometimes just referred to as the min, okay? When the graph is upside, like pointing down, opening downwards, if you go from left to right, you read it, and you get to the highest point here, it's still the vertex, okay? But in this case, it's not the lowest point, it is actually the highest point. So we refer to it as max on our calculators. Okay? What else have you got? What are these ones called here? This point and that point. What would you call that? X-intercepts. That's correct. Do you remember those? I hope you're not having bad memories of that from last year. And what is this one called that crosses right here? Y-intercept, right? So that is still with us, and it's just interesting that here you have more than just one x-intercept. When you did linear, you only ever had one of each, right? With quadratics, that's going to change. And so parabola is the name of the shape that you get from a quadratic function. It's always going to be a parabola, okay? All right, so let's dive in, and we are going to graph fairly quickly on our calculator, so have that ready to go as well. So page 2, I have to introduce a lot of terminology, a lot of concepts before we can start dealing with these, so it's going to be a little heavy on that today. Okay? Here we go. A linear function, a linear, has the equation y equals ax plus b. And you're probably thinking, what was that a for you normally? It was mx plus b. I don't know if you remember mx, and m was called the slope. I don't know if you remember that. It's not a big deal if you forgot, but that's okay. I'm going to use a for it, where a is the leading coefficient, okay? Write that down. That's going to come with us next year as well. Leading coefficient. Sorry, it's a little tight there, but it's called the leading coefficient. And the constant b is just a number, it's not attached to a variable, is the y-intercept. Okay? It produces a straight line since the highest power of x is 1. Okay? The equation has a degree of 1. So we always look at the variables, in this case it's x, and we look at the highest power that exists of x, and that's the degree of the function. Okay? Note, y equals ax plus b can also be written as y equals mx plus b, where m is the slope and b is the constant or the y-intercept. So I'm just reviewing that from last year. A quadratic function has a quadratic, so now we're switching gears, okay? A quadratic function, however, will have the general form like that. Although you're going to realize that it's sometimes going to look a little different, but you should always have the x squared somewhere in there, okay? Where a cannot be equal to 0. Like that, the coefficient in front of x squared cannot be 0. It can be 1, it could be 0.5, it could be negative 300,000, it could be anything, but it cannot be 0, because then this whole term would disappear, and this whole thing would turn into a linear, okay? And b and c may be 0, though. That is something that you need to be comfortable with. So these two terms here may be absent. You might just have something like that left over, y equals ax squared. And where a, again, is the leading coefficient. And the constant c, so you watch for c back here, is the y-intercept. It produces a parabola. Since the highest power of x is 2, right, x squared, the degree of the equation is 2. A quadratic function will always produce a parabola, and it points either up or down and expands sideways indefinitely. So this is probably worth highlighting. It expands indefinitely. So one thing that, if you are in grade 12, especially if the province sees you graph something, these tails here should never kind of appear to go inward like that. Don't copy this for now, but this would be a big no-no, right? A parabola keeps expanding indefinitely. So it's not a U. It's not a U. It's kind of like, it looks like a horseshoe, but it keeps on expanding indefinitely. So it says, state whether the graph is one of the following: a constant, linear, quadratic, or not applicable. So this one definitely is quadratic. It looks like the parabola that we've talked about. What about this one? Some of you might say, it kind of sort of does look like half of one, but this line doesn't indicate that it's going back up, correct? We have no indication. So based on what we see, it's not applicable, okay? Not enough information. That's what I would say here. I will just make a note. Not showing an increase here. It's not showing an increase. If you can read that, I hope you can write that down. And not showing an increase here at that tail, so we cannot conclude. This one is definitely quadratic. What about this one? Linear. Okay? What about this one? This is a constant. How do you know it's a constant? Right, it's flat, right? It doesn't have a slant to it. So if it has a slant, it's linear. It has an x term. This is a constant function. Okay? This is just y is equal to a number. That's what the equation of this line would look like. This one is NA. Okay? It kind of looks like a parabola. but let me, like you can never have it sideways. That is a no-no, right? So if you were to take pre-cal, you would talk about this one at some point, but for us it's not applicable, okay? So let's keep going. Equation function, so you've got you here. You're supposed to figure out the degree, type of function, leading coefficient, and the constant. This is technically the y-intercept. Okay, this is the y-intercept. Type of function, you've got constant, linear, quadratic. That's basically the options that I'm giving you, even though there's two that do not apply. So you can also say NA if it doesn't apply to any of these here. Okay? So I will do one with you, and then you fill in the rest for a bit, just a minute or so. Y equals 7 plus x. There's an x term right there. That exponent is 1, even though it's not there. So that's the highest exponent of the variable in question. So we have a degree of 1. The type of function is linear because it's degree of 1. What is the leading coefficient? Where would you find it? It's whatever the number is in front of the variable with the highest exponent. In this case, we're talking about x, right? What is the leading coefficient? Like what number is in front of x right now? It's positive 1, right? Yeah, so it's 1. Not 7. 7 is not a leading coefficient, right? It has no variable attached to it. What's the constant in this case? It is 7. Okay, 7 is your constant. It's that number that's on its own without a variable attached to it. Okay. One more. What's the degree of this function? It's kind of weird. It's 0, right? Because it is basically, it's almost as if I said x to the 0. Do you remember what anything to the 0 equals to? It's always 1. Anything to the power of 0. And if you forget, you grab your calculator, you try it, right? 5 to the power of 0. It's 1, right? That number to the power of 0, it's still 1. So anything to the power of 0 is always 1. Oh, sorry. I didn't mean to put plus there. That's my bad. This was supposed to just say it has an x to the 0 attached to it, which is just 1. That's why you get 15. So the degree of this is 0. This is a constant function because it has no variable. Okay. The leading coefficient, this one would be NA. Okay. Because technically we don't have a variable in there. So we don't have a leading coefficient. The constant is just 15. All right? Okay, I want you to try just this one for now. Just this one, f of x. I don't know if you remember that. This is just written in function notation. It's still the same thing. Everything else stays the same. But could you fill these things in if you got this thrown at you? Go ahead and do that for a few seconds. The rest I'll talk about. So here we go. The degree of this one is 2 because that's the highest exponent. It's a quadratic because that's got the x squared term. The leading coefficient in this case is -3. Just keep in mind the order of these numbers, of these terms, could be any way. Now it's nicely x squared x -5, right? But it could be different. So the leading coefficient is -3. The constant is just that number in the back, which is -5. And there you have it. For us right now, this one would have a degree of 3. Technically, I told you NA, but you know next year you're going to see that one. That's why I'm throwing it in here. It's actually a cubic. When you cube something, it's a cubic function. So I don't think it hurts you to already hear of it this year. What's the leading coefficient? It's just 1, positive. Okay. Is there a constant? I'm here to say yes. It's 0, right? It's just 0. There's a plus 0 following it. It's just not there. It's invisible. Okay? 1 over x, I'm going to say it's not applicable. Okay? We're just going to say not applicable. The leading coefficient is 1. The constant is 0. Okay? And the last one here. I thought, you know what, I want to review FOIL with you a little bit because it does come back from time to time. Do you remember how to FOIL things? Yeah? I don't necessarily follow that. I just tell you this, okay? Take this first term, multiply it like this. You distribute it. Right? So the 6 you leave out. Don't bring the 6 in just yet. But leave it outside. But x times x is x squared. X times positive 3 is positive 3x. Then you go to the next term here and you multiply it like this. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Okay. And you can combine like terms. Let me zoom into that because it's very small there. Okay. How's that? Okay. So technically you have x squared. The 3x and the negative 5x result in negative 2x. And the negative 15 it just stays. So you've combined like terms. I don't know if that also rings a bell for you. Okay. Now we distribute the 6 across this whole thing. So it's 6x squared. 6 times negative 2 is negative 12x, correct? And then 6 times negative 15 is negative 90. So technically f of x looks like this when you distribute. This is what do we call this form? This is what we call the general form. That's how we would like it to be if at all possible. And don't worry about it too much. Foiling is going to be very minimal, but I think you need to be comfortable with it. So what's my degree of this function? It is 2. It is a quadratic. The leading coefficient in this case is 6 positive, and the constant is negative 90. So that's how you do one that has brackets, right? This is factored, by the way. This is the factored form of the quadratic, which you will encounter, but you will be able to type it into your calculator, and voila, it's just going to graph it for you. Okay? So don't worry about it too much. All right. There you go. And it's not just going to happen after today. You're going to have to practice it and struggle with it a little bit. But please put the effort in. This one is definitely going to pay off for you to try, okay? Keep going. Here you have your 3 forms of the quadratic equation, okay? This is on page 3. Forms of the quadratic equation. This is the 3 that you're going to encounter. This is the most popular by far. The one that looks like this. That's in general form. Next, you have the descriptive / vertex form. Don't worry about it too much just yet. That one looks like this. I will come back to this one. But notice there's always going to be an x squared somehow if you FOIL it out or do whatever. Then you've got the factored form. This one looks as follows. You've got a, that's x plus r, x minus s. It's not 5, it's an s. And I didn't come up with the letters. Some folks that are way smarter than me decided that that's the letters that we're going to use, so we're just going to go with it, okay? What do you notice about these two? What's different about these two compared to that one? I don't know if you noticed, but these two have brackets, right? So I just tell my students, these have brackets, okay? If something doesn't have brackets, it's automatically in general form. If it has brackets, you have to watch out. It's going to be in one of these two, okay? The general form gives us right from the get-go the y-intercept, okay? That's the nice thing about the general form. It gives us the y-intercept. It's always going to be that last number here. So it's 0, c. That is the y-intercept. As a coordinate, right, x is equal to 0 at that point, and c is that variable right there. Sign and all, please. Like if this is -5, then you put -5 in there in your coordinate, okay? That's what it gives you. What does this one give you? It gives us the name says it, the vertex. Do you remember what the vertex is? It's either the highest point or the lowest point. So we usually go vertex like this, and this is where you have to be careful. I'm going to use a red pen for this one. You're going to grab the h, that is going to be the x coordinate of the vertex, but you need to change the sign of whatever is in there. So I'm going to go -h, comma, k. This number that's going to be outside is going to be the y coordinate, right, of the y component of your coordinate. So this changes the sign, okay? Change sign. That's what a negative does. When I just make it show up, it says, oh, whatever h is in here and your original, you're going to change the sign of it when you bring it into this coordinate, okay? So you got to remember that. What about the factored form? It gives us the x-intercepts. I'll say intercept or intercepts, because actually it turns out that there could be more. There could be 0, 1, or 2 actually. More about that, more on that later. So what you do is, when it's like this one right here is going to give you the first x-intercept. That's what we're going to do. We're going to change the sign if you bring it out of the bracket into the coordinate. So this is -r, 0, and -s, so whatever that sign is, you're going to change it like this and go 0. Wait a minute, why the zeros, Mr. Dirksen? Why are you saying that? Because x-intercept, right, that's where you cross the x-axis. At that point, x is, or the y is equal to 0. That's why that is. Okay? So I'm going to just piggyback off of this one and just say all of these ones are also changing the sign. So change the sign. I'm going to use a different color, something that stands out. Okay? I would strongly recommend that you have this on your study sheet. So under quadratics, I would already say these are the 3 forms. Okay? And make sure you indicate to yourself that, right, there are 2 forms that have brackets. As soon as there is no bracket, you know it's in general form. That, I think, is the most important thing actually out of all, to notice that. Okay? Do you want me to put that down here, no brackets? A few exclamation marks. Okay? So you know down the road, because sometimes they look ugly, guys. I have to say, sometimes the functions look scary, but don't worry about it. This comes to your rescue. You can feed this anything you want. It'll take it like a champ. All right? This one will take it and do it for you. That's where applied is like it's different than pre-cal. Pre-cal, everything I give you has to be either factorable, you have to be able to factor it, or somehow work with it so the numbers are a little easier. Because we're using technology, I can give you the ugliest equation that actually matches with real life, and you just type it in and you go with it, right? So we can actually deal with more complex cases because of this, right? So I love applied for that reason. So here we go. Regardless of which one you're given, we simply type them into our calculator and use second trace to find additional information about the resulting parabola. Please don't forget that. Okay? Some students freeze when it's oh, I don't know which one. Just type it into your calculator. Type them into your calculator and use second trace. I'm gonna show you what I mean with that. That's how you extract information from a graph. Okay? Most of the time, you'll be given the equation in general form. We will start this unit focusing on that, and then we'll introduce the other ones slowly as we go along. So this is the most popular, okay, most popular. When you're given that one, you can actually, right off the bat, guys, know a lot of information about the resulting parabola. Like for instance, you can know the direction of opening, okay? The direction of the opening can be determined by the sign, write that down, by the sign of the leading coefficient A. So if A is positive, you know your parabola will be doing this. If A is negative, you know your parabola, if you type that into your calculator, it should look like that. It should be either pointing up or down. I need you to know that. I don't want, because sometimes you type it in wrong, and it's pointing up, and you're like, wait a minute, my leading coefficient is negative. Why is it pointing up? You made a mistake when you typed it in, right? So those are things that I just need you to know and troubleshoot as you go. Also, you know the width of the parabola, how wide it's going to be. And here's what you need to look for. You need to look for the value of A, not the sign of A. Whoa, what? So a normal parabola kind of looks like this. Just follow my train of thought here. Kind of looks like that. This is where A is equal to 1, okay? A is exactly equal to 1. I'm breaking the lead like there's no tomorrow today. Okay? A is equal to 1. It's a normal parabola. It could also look like this. It doesn't matter. The width, we're talking about the width. So A is equal to 1 or A is equal to negative 1. It doesn't matter. It would be a normal parabola. We don't look at the sign, we look at the value. Okay, folks? We look at the value. It's 1. So a wide curve would be happening if A is between 0 and 1. Sorry, it has to be less. It can't have the equal sign. Sorry, my bad, my bad. Please get rid of the equal sign or else we're in trouble. It's just anything in between 0 and 1 will result in a wider parabola. So we're going to make sure we do that. Like it's going to look more like this, like a wide parabola like that. It's going to open up wider and wider as those numbers change. Okay? It could also look like this. Okay? Examples. I'll just give you examples. A could be 0.25. A could be negative 0.02. Right? So if you look at the value itself, anything between 0 and 1 is fair game. Okay? Anything between 0 and 1 would be considered a wider parabola. Then there's equal to 1, that's our normal parabola. And if A is greater than 1, you have a narrow parabola, so it's going to be like, it's going to shoot up really quick. Okay, it's going to be narrow like this. You know what? I always levitate around the center. It doesn't have to be. It could be way over here. Okay? It doesn't matter. So you could have examples. You could have A is 2.37 or A is negative 304.9. It doesn't matter. If the value of A You're listening, right? Because it's Monday morning. If the value of A is bigger than 1, it's going to be narrow. And the bigger that number gets, the narrower your curve is going to become. Okay? I think we're going to let's have some fun with the calculator for this part right here. Okay? I'm going to ask you to grab your calculators and just follow my lead on that one. Okay? So you grab your calculator, and I'm going to try to have my buttons showing as well. Okay? Whenever you want to graph something, we're going to go to y equals. And there you should have a bunch of y's, right? y1, y2, y3, all of those y's are in there. Yours are probably pretty packed, because if students used them before you got them, there might be stuff in them. Can you just press clear everywhere and make sure nobody pranked you and put one way down here? So go all the way down, make sure y0 is also cleared. Okay? That's first instructions I'm going to give you. Make sure you clear everything. The next one is, I need your plots to be not like unselected, deselected. So if you look at your screen, there should be no highlighting here. So let's say your plot 1 is highlighted like that. Make sure you go to it and press enter, and then go back down. None of them should be highlighted. None of those plots, because that's going to give you a bit of an issue at times. We're going to use them later. Okay? All right, now you're with me, right? So let's type in, let's go y is equal to x squared. Let's just make a regular x squared. And this is what you got to use. This button right here, I'm going to use my pencil. This one, x, t, theta, n. That is your x button, your variable x. So you press that one. Don't press times. It's not going to work for you. It has to be this one. And let's go hat to the power of 2. X squared. You got that? Your equal sign should be highlighted immediately. As soon as you type anything in here, the equal sign should be highlighted. If it's not, you're not going to graph it. So press graph right now. Let's see what happens. I got that. Anybody not seeing anything? It could be that you're not seeing anything. You want me to tell you? I'll tell you one more time. y1 is going to be x squared. You're going to press that button, and then either x2, or you press the hat button followed by 2. It's up to you. Then you press graph. If you don't see anything, this is what you're going to do, okay? We're going to press zoom. Zoom is going to save you a lot of times. Zoom is up here. See where my finger is? Zoom. You press zoom, and this is one I'm going to suggest to you quite often. Zoom standard. Zoom standard is a standard window that is 10 by 10 by 10. Hit enter. As soon as you go to zoom standard, you hit enter. That's what you should be seeing. Let me see if I can. Is that working for you? Yeah. So let's try something else. Let's press, oh. Yeah. Yeah, I don't want to repeat everything. That's too bad. This is in vertex form, not in general because there are brackets. But the A part never changes. This is still A, right? Whatever's in front of the whole thing is always A. For basically all of them, it's in front of the x squared term. So A is negative, so this is going to be pointing down. And it's going to be wide, correct? Because 0.91 is between, it places A in between 0 and 1, so we're expecting a wider curve. And this is where you cannot say, I think you might be tempted to say 0, -3 is my y-intercept. You cannot say that. This is where this comes back. If it has brackets, then it's not in general form, so what do you have to do to get the y-intercept? You have to use second trace 1, x is equal to 0. What is it? What are we talking about there, Mrs. Erickson? I'll show you, okay? So we're gonna go typing this into y1. We're gonna go y1 is equal to negative 0.91 x plus 2 squared minus 3. So let's go ahead and do that. Can you type that in, please? I'm gonna go to y. Let's clear everything we've typed in. Just hit clear, clear, clear. Nothing else. We just want everything cleared up. Then you have to type in negative 0.91. Use your brackets. Type it in exactly the way you see it. X plus 2, close the brackets, to the power of x, right? It's x squared. And then it's minus 3. Can you just pay attention to this? If your cursor stays up there when you do an exponent, make sure you go sideways arrow to bring it back down. Don't be typing in stuff into your exponent because it's going to be a weird function, right? So if it's hovering up there, make sure you go arrow to come back down. Okay, so that's what I have. I'm double checking. Let's hit graph on this one. Graph. It's on our screen, so that's good. How do we find this? You got to follow me now. I'm going to type this down. I'm going to first write it down. We're going to go second, trace, and then select option number 1 for value. And then we're going to let x is equal to 0. And that's how we're going to find our y value. Just trust me for now. We'll do a lot of this, okay? So second, I press second. Then I press the button, the trace button right here. Second trace. Make sure you press second trace to get to this screen right here. Then we're going to select value. So that's option number 1. So you hit enter. Every time you want to access, you just hit enter. And we're going to let x equal to 0. Because remember, if x is equal to 0, you're going to find your y-intercept. So we're going to let x equal to 0, hit enter, and what do you get there? Negative 6.64. Okay? That is the y-intercept. So 0, negative 6.64. We like to state the y-intercept as a coordinate in this course. I know that last year you may have gone y is equal to negative 6.64. We don't do that in applied. We want it as a coordinate. Okay? I think this is worth highlighting that I did this, right, to come up with that y-intercept there. Why did I have to do this? Because this wasn't in general form. Okay? It wasn't in general form. Page 4, the bottom part, I'm going to put homework down. I want you to do what we did today on your own. Okay? And unfortunately, it didn't record all of this. I'm just going to grab a random one, this one. Right? How did I fill in this thing? I looked at a, which is the leading coefficient, which is in front of the x squared term. It was negative, so it opens down. It was narrow, because I just look at the number, 7.81. I know it's bigger than 1. And my y-intercept, don't use your calculator. You know it's in general form, so it's just 0 constant, right? 0c, so 0.9. So you do the same thing. Is this one general? No. You're going to have to use your calculator for the y-intercept. This one is general, this one is general, general, not general. So 2 are going to be calculator based, okay? So try your best. Let's keep going. I know you're like, I thought we were done already, Mr. Dirksen. Not quite. So there might be very little homework. Maybe the chart is all that you're going to have to do for tomorrow. And maybe already start beefing up your study sheet, adding to it. Page 5. Other properties that can be determined using the calculator are the vertex, the coordinates xy of the point where the parabola changes direction. Okay, so what is the vertex? It's the point where the parabola changes direction. It could be the highest, which is the maximum, or it could be the lowest, which is the minimum point. So we determine that using our graphing calculator. Okay. So here we go. If you could have one that's pointed this way, just make sure it keeps opening up indefinitely. It shouldn't curve into itself. Okay. So the vertex would be there. So it has x, y coordinates. That's the vertex. And in this case, it's the lowest point, right? Lowest. So to find it, we would go second, trace, min. Okay, that's how we would find it. Let's make one that's a little wider, okay? So if you have something like this, could be, you know, the trajectory of you tossing a can of pop into the garbage, right? It'll have a path like that. So this is x, y. It will have a coordinate x, y. And so this is the vertex. But you have to understand that if it's like this, it's the max or the highest. Okay, max or highest. So you would use the calculator, and then you type second trace max in this case. Very important that you type max, and in this case you have to type min to get it, or else it will not find the right point, folks, if you get that wrong. So this is where you come in. You have to figure out, is it min or is it max? What do you think the leading coefficient will be when it's like this? Positive or negative? Positive, right? Then you will have to use the min function to get the vertex. If it's pointing down, we know that our leading coefficient is negative. So then you have to use max. So you'll have various ways of confirming whether or not you're doing things right. Let's keep going. The coordinates of the vertex provides us with two additional pieces of information. It gives us this, and it gives us this automatically. So once you find it up here, you find that exact coordinate, it gives you two extra pieces of information. Both of them are equations, okay? So it gives you the equation of the axis of symmetry, and it also gives you the equation of either the max or the min. I will use orange and green to highlight those and then show them on the graph for you. Axis of symmetry, I'm using orange. AOS, that's going to show up a lot. And then max or min, I'm going to use green for it. What is the axis of symmetry, you may ask? It's right here. It's a vertical line that cuts the parabola in identical halves and goes through the vertex. That's what the axis of symmetry is. It cuts it in half. Okay? So, this is your vertex right here. Right? This is the vertex. You got it. It's 2, 3. Watch the coordinates 2, 3. Right? It makes sense. I already gave it to you. So in this case, visually, the axis of symmetry is actually an imaginary line that cuts through it in half. So it has to go through the vertex. Do you remember what the equation of a vertical line looked like in intro? It's x equals a number, and in this case the number is 2. Okay? So this number 2 gave us the equation of the axis of symmetry. This is the equation of axis of symmetry. So if you were to graph it on your calculator, which I won't show you just yet how to do vertical lines because it's a bit of a cheat that we have to use to make that happen. That's what that would be. So that's one of the pieces of information. There's also one that goes through the vertex sideways. That is, in this case, what would it be, a max or a min in this case? Left to right, max, right? So the equation of the max in this case would be a horizontal line that goes through the vertex like that. And in this case, it would be y is equal to 3. Okay, so this 3 is what I came up with there. So these are both imaginary lines, folks. These are imaginary lines. They come from the vertex. So this is the equation of max in this case. So the vertex gives us these two pieces every single time. Every single time you just find the vertex, you know these two right away. Okay? What about this one? Well, the axis of symmetry would cut it right, would go through the vertex vertically. Okay? And what equation would this be? Is it min or max? It would be min in this case, right? It would be min. So this is still the equation of axis of symmetry. And what would it be? X is equal to, let's go to your vertex, negative 2.3. And this gets ugly. These numbers are going to be, like, get used to it. It's going to be all right. And then this one is the equation of min in this case, which if I ask you for it, you just go, oh, this is what it is, Mr. Erickson. It's y equals negative 3.5, right? So again, I'm going to use arrows. I'm going to go from my vertex and say that's where I got that number from. And I'm going to go from my vertex. I don't need you to do this on a test or anything, AC or anything like that. I just need you to know where did I get those two pieces from. And a lot of students leave these blank. And I'm trying to make you see that they're actually fairly straightforward. You just state it. This is what a common mistake is. I ask you, what's the equation of the axis of symmetry? And some folks will just say, oh, it's negative 2.3. Is that an equation? Equal equation, right? Think of that. It has to have x in front of it. It's a vertical line. Okay? And the other one is a horizontal. Maybe I will highlight that part, that the AOS is vertical, the max or min, that equation is horizontal. I know, it's a lot. I'm overloading you with info, I know that. But I hope to be at least page 6. I want to finish page 6, and then all you have to do is the table on page 4. That's all I'm going to ask you to do for now. Graph it and see if you can figure that out using your calculator. Let's go to page 6. The x-intercepts. Everything here is calculator. Everything on page 5 and 6 is like, how do I use my calculator? Quadratic functions can have up to 2 x-intercepts. Notice a pattern for applied 40, that's next year. Here, highlight this. The degree of the function tells you how many x-intercepts are possible. So, linear, what's the degree? Degree is equal to 1. 1 x-intercept possible. Quadratic, what's the degree of that? 2. 2 x-intercepts are possible. What's the cubic again? Cubic, this is next year. What's the degree of a cubic? How many x-intercepts? 3 possible. It doesn't mean it will always have 3. It just tells you that that's how many are possible. Okay. So here are 3 possible scenarios. I tell you can have up to 2, correct? So you can have no x-intercepts, 1 x-intercept, or 2 x-intercepts. How would you have no x-intercepts? This is what needs to happen. The vertex, I'm going to summarize this, okay? Vertex above x-axis vertex above x-axis and points up. We know that A is positive if that happens, right? So I'm going to use a red pen, I don't know. So the vertex, if it's above the x-axis, it could be anywhere above this one, right? So let's say it's here. I'm just randomly choosing that location. By the way, when I graph parabolas, I start with the vertex usually, and then I go out this way, and I go back to the vertex, and I go out this way. I try to copy, because both arms are exactly symmetrical. They are the same. What's the other case going to be? The vertex is below x-axis and points down. So anywhere, let's put the vertex anywhere below the x-axis, somewhere in here. Let's make it a little narrower, like that. You can tell it's never ever going to cross the x-axis. So no x-intercepts there. That's one scenario. The other scenario is one x-intercept. That means that the vertex is on the x-axis. Vertex is on the x-axis. So it could be here somewhere, and it could be pointing up. Or it could be somewhere on the line here and pointing down. As you can tell, pointing up or down doesn't change a thing. The vertex is right on it, so there's one x-intercept. I'm going to make a note. Note. Vertex is also the x-intercept. It's both. In this case, the vertex is also the x-intercept. Last but not least, maybe that'll be your homework. Vertex is above x-axis and points down. Let's finish this. Or the vertex is below x-axis. It's below and points up. So this is what it looks like. Vertex is above, points down. So you've got two there. Vertex is below the x-axis and points up. Obviously, as you can tell, both of these scenarios have two x-intercepts. Homework is page 4. And maybe just reread the notes, okay? Have a good one, guys. I'll see you tomorrow.